This short video will show you how PTC's best-in-class products, Creo and MathCAD, can be utilized to improve the way you design. In this structural engineering problem, we'll demonstrate how it's possible to quickly identify and validate the selection of a suitable profile for a simple elastic beam. We'll do this by making use of supplier data in an Excel spreadsheet, performing and recording our calculations and design decisions in MathCAD, performing some trade-offs in identifying the required section, confirming the requirements set out for the design have been met, and finish with the validation of the design. Here is an overview of the steps involved. First, we will read in the data and perform some sizing calcs in MathCAD's unique and intuitive environment. The calculations allow us to confirm that requirements have been broadly met before proceeding to a more detailed simulation. Once we have this confirmation, the model in Creo is linked to the results from MathCAD, thus creating an updatable model. Finally, the Creo part can be validated against the predicted outcomes in MathCAD using Mechanica to perform structural analysis. Here we have a tightly integrated set of tools that allow you to easily update the model details and associated analysis should there be a requirement to do so. Take the example of the simple I Beam. We can, of course, assign the values for our preferred section directly in the model. But if we take this a step further, it's possible to update the cross-section details based on the outcomes of a MathCAD worksheet and save this process so we have a ready-to-use framework allowing quick and efficient reuse. This is done with an analysis feature in Creo that allows us to directly pass data to or from MathCAD to Creo. So in this MathCAD worksheet, we have a large selection of cross-sections available. The worksheet has been configured to show this as a list for quick and easy data selection. This data can be used in our calculations to understand whether our design is suitable for its intended purpose. The calculations here are referenced from Rourke and Young Handbook for Stress and Strain, provided by Novel Solutions. We can perform some trade-offs in the design process, trying to get a handle on what would be the most suited section that ensures requirements have been broadly met. Once we have identified the most suitable section, we can lock in our preferred section selection and save the worksheet. As we look through this worksheet, notice that we have included calculations to perform stress calculations for maximum bending stress and shear stress. We can use the results to compare and validate against a Pro Mechanica model. We are now ready to pass over the selected cross-section and other relevant beam specifications to Creo. This is achieved using a defined mapping sequence that needs to be done only once during the setup process. In this example, we have 5 MathCAD variables that will map directly to 5 Creo parameters. On updating Creo, notice that the beam updates based on the selections we made in MathCAD. This updated beam can be used for providing validation in Mechanica. A simple analysis is set up to show the concept using Mechanica's process guide. The finite element simulation is able to give us a clearer picture of the behavior of this structural element. It is important we can marry the results that both MathCAD and Mechanica provide. This gives designers greater confidence that what they have predicted in MathCAD is reflected in the Mechanica analysis. The obvious benefit of integrating Creo and MathCAD is the seamless integration of calculations, geometry, and simulation that can be called up for future audits, reuse, and potential rework in a fraction of the setup time required in traditional setups. Let's look at this example in the context of design processes. Process improvement is crucial to improving product development and business success. PTC has a comprehensive point of view of product development, and it's represented here in our process landscape. We recognize that product development is a set of highly cross-functional and distributed processes that span the life of the product from planning through support. Let's focus briefly on some of those processes that impact the engineering organization in particular. Let's consider concept development. Whilst MathCAD captures and conveys the intelligence we build into our designs, as well as the thought processes and the engineering methodology used, Creo gives us the best CAD platform to access, view, and edit these design concepts. Used together, they allow us to improve our ability to make those early design decisions that can impact future downstream work and associated costs. MathCAD is used to record those decisions, be it for future reuse or in support of compliance to codes and standards such as Eurocodes. Another process where MathCAD and Creo work well together is verification and validation. MathCAD can be used to check current geometry against the initial requirements. In this demo, we saw how the current parameters were insufficient in the event of an updated requirement. MathCAD also helps to establish confidence in the design process with an independent validation of the simulation results from Mechanica. We have seen in this short video the benefits that Creo and MathCAD offer. When used both independent of each other or in a tightly integrated way, the clear benefits here being reduced time in design iterations, improved quality with less chance of errors, and confidence that designs have been delivered fit for the purpose they were intended. Thanks for watching.